Continuous random variable x has a probability density function f of x, where f of x is defined as kx for x between 0 and 2, and k times 4 minus x for x between 2 and 4. In order to find that constant k, we are going to use the fact, and we're going to use the idea of total probability. So that means we're going to use the fact that if we integrate over these two ranges the individual functions f of x and put them in a sum, then the total probability that will occur from this is of course 1. So I'm going to integrate each function separately. So I'm going to integrate between 0 and 2. For this function I'm going to take the k, the constant, outside, just so I don't have to worry about it, and so I can just focus on integrating x. It's not particularly difficult, but it just gets you in the habit of doing it for perhaps more complicated expressions. So integrating x, I get of course x squared, and I'm going to divide that by 2. So I'm going to evaluate that between 0 and 2. So just showing my substitution stage fully, 2 squared over 2 minus 0 squared over 2. I get of course 4 divided by 2, which is 2, take away 0, and so I get an answer of 2k. And of course you can evaluate this on a calculator if you need to, but these simpler evaluations you should be able to do without your calculator. Okay, so let's now integrate the second function. Again, I'm going to take the constant outside just as we did before, so I'm going to just put k times the integral. This time we're integrating between 4 and 2, and I'm integrating 4 minus x dx. So always make sure you don't forget the k, so I get k times the result of integrating my function. 4 is a constant, so it just integrates to 4x. Take away x will integrate to x squared, and of course we're going to divide that by 2. So close that bracket and put the range for which I'm going to evaluate that. So this is now going to be equal to, showing my substitution stage, I'll put my 4 in, so I get 4 lots of 4. Take away 4 squared over 2. Remember to show your full substitution stage, don't do any simple calculations along the way, show that you know how to do the integration properly. So I'm then going to get evaluating the 2, so I'm going to get 4 lots of 2 minus 2 squared over 2. Okay. Now, when we put this into our calculator, what you're going to find is it works through, and we get 16 take away 8, which is 8, and we get 8 take away 2, which is 6. So 8 take away 6 will give you 2 times the k, which is 2k. So going back to my original property, having evaluated both the integrals over both the functions over the range they are valid for, I take the values of the integrals, which are both 2k, and I sum them so they both equal 1. So it gives us the answer 4k equals 1, and dividing both sides by 4 just to get left with my k, I get that k equals a quarter. I hope you understood that all.